Hey class, welcome to the week 5 vlog. I've got my party hat on because reading week is coming up at the end of this week, so that's something to look forward to. And I know it's a difficult time for a lot of us for a lot of reasons, so I hope you're able to take advantage of that and get back on track wherever you need to. Two of the things I want to talk about today are kind of linked with that, and then I have one other technical thing about composting calculations that I'll put at the end. So firstly, I just wanted to talk about kind of course expectations around the deliverables, because I know some people have been worried about what to put in them and what's going to be good enough. And I just want to encourage people that the focus for the labs and the project is not to write a lot, not to do a lot of formatting, not to try and anticipate every single thing I could be looking for. It's really to focus on the core content and to stick to exactly what's requested in the rubric. So don't try and make everything super polished, super amazing. Stick to what's really important in the content. And with the project, it's built with milestones. So at each milestone, I'll give you feedback on how you're doing. And if I think that you really need to do better in some area, I'll tell you in each milestone, and it's set up like that to try and decrease kind of the amount of worrying you'll have to do. So if there's something that you really did poorly in one milestone, I'll let you know. And if you fix it in the following milestones, then you'll be fine. With the labs, similarly, I know some labs you'll try and write like a 10-page introduction and cite all these papers and have a big discussion and things like that. With our labs, they're very step by step. I know there's a lot of steps because we try and give you exactly each step to follow because it's hard to do it otherwise with the asynchronous learning. But really just focus on following those steps and answering exactly what is asked there. If you have other things you want to talk about, that's great, but you don't have to impress us by writing a whole bunch of other stuff. We just really want you to know how to use these models and be able to put that on your resume and things like that. So if you have other questions about expectations for the lab and the project, please let us know. Don't stress out trying to guess what we want. We really just want to focus on the content, so don't try and do anything too fancy. If you do get in a place where you're very worried about your grade, please talk to me and we'll see what we can do to make up your grade in other ways. We really want to make it as easy as possible. We all have a lot of things to stress out about right now. So I just want to say for this course, if you have concerns, please raise them and we'll try and deal with it early and in the easiest way possible. My focus is on getting you familiar with the content and getting you interested in solid waste. So if that doesn't make you feel better, please talk to me. Hopefully that makes some of you feel better. Also, since we're at the midterm point in the course, I'm going to send out a very, very short survey with the weekly announcement this week, just asking you how things are going and what suggestions you have, because we've got a whole another half of the course coming. So if there's things you want to tell me there, please do, or you can tell me in an email or whatever else is comfortable for you. So that's kind of all I want to say. I hope you have a good last week before reading week. I hope you have a restful reading week, and now I'll show you some compost calculations. I received a question about the Chapter 4 progress quiz where it's asking about calculating the aeration requirements for a compost system. So I just wanted to give some background that will hopefully help you picture what's going on there. So it's important to remember that compost is made up of a whole bunch of materials. So inside this pile, we've got a whole bunch of moisture, which I'll make these blue dots. We've got solids that are going to be degraded through the composting process, which I'll make these green dots. And then we've also got solids that we know are not going to be degraded. So those are those humic substances that are going to remain at the end of composting, and that's the actual compost that we'll put in our garden. So I'm going to show that with these brown dots. And then we have also all this air that's left over, which is the space that's remaining. So if you actually think about what's in this material in terms of a pie chart, there's a certain fraction of solids, and that's broken up into material that will degrade and material that will not degrade, and then a bunch of moisture. And I'm not showing the air here because this is just looking at the mass. So when we're talking about the aeration requirement, we need to recognize that it's just this green fraction that is actually going to react. The water is not going to react, and this portion of the solids that is going to be left over at the end of composting is not going to be broken down. At least it might react, but it will stay in the compost. It won't be released as CO2 and lost as mass from the pile. So when we're calculating our aeration requirement, we're going to focus on this green sector. And the way to keep yourself kind of on track through this whole process is to look at what your units are. So say I have 1 ton of wet compost. And at the end of my calculation, I want to get to however many tons of air. I need to do a line calculation that compares wet tons of compost to tons of air by the end. And as long as I match my units all the way along, I can be confident in the answer I get. So the first thing to do is convert the wet waste of compost into the dry waste of the part that's going to degrade. So we need to know out of each ton of wet, first how much of it is solids, and that will get us into tons of wet, and then how much is degradable solids, and that will get per ton solids, and that gets us into degradable ton solids. I'm going to run out of room on this line, so I'll just move down. So we'll get to this equal sign later. So we're at degradable ton solids. Now we need to figure out how much oxygen do we actually need from that. And in the question, I've given you an empirical formula, so we can get to the number of moles, because moles are useful for doing things on a molecular level, right? So we have degradable ton solids. We want to get moles of our representative solid molecule per ton. And then we'll cross out this, and we'll cross out this. Now we have moles. Now, because we're on a molar basis, we can look at how many oxygens are needed per each molecule we're representing this with. So it could be like 2 oxygens for each molecule, 3.5 or 4.2, whatever it is. So moles of O2 per mole solids. We're getting closer. So moles of O2, we need to get to tons of air, so we're almost there. So if we want to get into mass units, we can use grams per mole of O2, the molar mass. Now we're in mass units for O2, and then you also need to know the oxygen content of air. So it's 21 by volume, 23% by mass. So we're in mass units here. So then we can go grams oxygen. We have 23 grams of oxygen per 100 grams air. And then you can just do a unit conversion, and then you'll be into tons air per our basis of 1 ton wet compost. So all you have to do is know what you're talking about, what these pieces mean, and keep your line calculation units in order with each other all the way down.